In this tutorial, I'm going to show you how to make a HappyBrackets composition from scratch. We're going to generate a sine wave and then modify its frequency with an accelerometer. Also, we're going to have a look at some methods to help find out why your composition is not doing what you might have thought it should do and how we can fix that quickly. To create your own composition, click on the source folder in the project, right click, and then press New Java Class. Then in the kind, click HappyBrackets Sketch. We'll give this name My First Composition. Then press OK. You can see a whole heap of code has automatically been generated for you. Below the line that says HB Reset, start to type the word Basic Wave Player. You can see as we've started, it's suggesting a couple of names. Select Basic Wave Player. This is a live template that generates some code. In a sense, it's a bit like a macro that enables you to create often repeated Java code. You'll be given the option to replace the default values. The first option is the initial frequency. You can see that it's defaulted to 1000, but let's make it 2000. Just type 2000 and press enter. Now it's prompting you for a volume. Let's leave it at 0.1 and press the enter key. You can see the editor jumps you right to the place where you need to start manually writing code. Let's compile and run this right now, just to make sure that it works. Right click and press compile. Now do the same and press run. You can hear a 2 kHz sine wave. Press the stop button to stop the sound. Download your composition to the device as you did before. Press the refresh button and you should have My First Composition displayed in the drop down. Now press the selected button. Alternatively, you could right click and click Send My First Composition to the device. You should now hear it on your device. Click the reset button to stop the sound. Let's examine our code to see how it works. We have a wave player called Waveform Generator that's generating our sine wave. The wave player is added to the input of a gain object called Gain Amplifier. This gain object is added to the input of our audio output. We set the frequency of our wave player with an object called Audio Frequency, which we have initialized to our initial frequency value. Any time we change the value of the audio frequency object, the frequency of the waveform generator will change along with it. In the same way, the gain object is controlled by an object called audio volume. The same applies, that if we change the value of audio volume, we will change the gain of gain amplifier. So we said that if we change the value inside our audio frequency object, we would change the actual frequency we hear. Well, let's try this with an accelerometer. Let's add an accelerometer to our code. At the last line, before it says type your HB action code above this line, start to write the word accelerometer sensor. Again, you can see IntelliJ is suggesting what you might want, so just press enter. You can see our accelerometer sensor code has been generated for you and your cursor has been placed right where you need to start typing some code. We want our frequency to go up and down when we change the accelerometer. You can see that the variable xval has the accelerometer value, so we will set the frequency to this value multiplied by, let's say, 2000. Go to the point where it says write your code below this line and we'll go float new freak equals xval times 2000. Now let's set the value of our audio frequency object. You can see IntelliJ is prompting me. It knows just what I want to type in. You can see that we're using IntelliJ's auto-suggest features to make our code typing quicker. Let's compile our code and download it into our Pi. We can see that what is happening is that when our device is level, we hear nothing. But as we go up or down above this level, the frequency increases. Also, notice that the frequency increases as we go further below the level. That isn't really what we wanted. So let's see why this is and what we can do about it. Reset your device to stop the sound. First, let us run it in the simulator to see what happens as we simulate our accelerometer. Right click and select Run. Let's see what happens as we change our values. As we scroll either away from 0, we get an increase in frequency. We can also enter specific accelerometer values by typing them in and pressing the Enter key instead of using a scroll bar. This tells us we need to change something in our code. Press Stop. Let's examine the frequency value we are setting our audio frequency object to by displaying or printing it on the Java standard output. This is what's known as seeding a value. Printing a value to the standard output is done in Java through the function system.out.println. IntelliJ have provided a live template shortcut by allowing us to type SOUT and pressing the Enter key. SOUT is a live template that changes the text SOUT to system.out.println. You can easily see what live templates are available for you by pressing Command J and scrolling through the list. Press Escape and just type SOUT and press Enter. Now type the value of our new frequency inside. Now run the code again and we should be able to see the value inside the console. We could see that the frequency was going between -2000 and +2000. If we look inside our accelerometer code, we can see that X value goes from -1 to +1. When it's level, the value is 0. 0 times 2000 is equal to 0, which is why we heard nothing when we were level. As we moved higher towards 1, the frequency was moving towards 2000. As we moved below 0 to -1, the frequency moved towards -2000, which is basically the same as 2000, but in an opposite phase. We need to change our formulator for calculating our new frequency. There are probably 100 ways of doing it, but I'll just do an easy way. The first way is we can add 2000 to our already calculated frequency and then halve it. Let's try it out. We can see now that the sound is behaving the way we want it to, increasing to 2 kHz on maximum and going to 0 on minimum. Press stop. Download it to the device and see if it works. You can see that it's operating as we expect. The frequency is now in the middle when we level, lowest when facing down, and highest when facing up. Press reset to stop the sound. We can also view the standard Java output of our device in the device log. This can be particularly useful for analysing or debugging your composition during a performance. First, right-click the B button and click Show Controls. Expand the debug and press Start Device Logging. We can see our frequency displayed in the log, and as we move or change the accelerometer, the text in the log is changed also. Now, just one thing we might want to think about. When we look at our calculation code, we're using the value 2000 in our code in various places. This is known as a literal or a magic number. And the problem comes when we want to change that value. If I wanted to change it to 1000, I have to change it everywhere. Right from our initial value up here, down inside my calculations. A better way is to use a constant or a variable value and change it in the one place. In Java, we use uppercase letters in a variable name to denote that it's a constant. Whether it's typed in uppercase or not does not affect the actual function, but it does make it easy to see that it's a constant object. So let's change the code so we replace all our literal values with a constant. First, our new frequency. And in our calculation, let's run and see if it works. So let's make it so we have our maximum as 1000. Just change it in the one place where our constant value is defined. So that's it. You've seen how to make your own composition from scratch, add a sensor, and then make some calculations to get the frequency we want. We also looked at debugging by seeding values to the standard output.